All right, thank you. So, welcome to today's class, and we are going to discuss or going to do now the regression analysis, okay, practical in Excel. All right, yes. So, before that, just to do a recap of what we discussed earlier, we said that regression analysis basically is used to estimate that is a relationship between what? Between two variables. Okay. Yes. So basically, regression. It's trying to estimate the relationship between what? Between two variables. Okay. And see how maybe we can use the historical data, create a model, and be able to do what? To predict about maybe the future. Okay, I know you know that is the difference between data analysis, okay, data analysis and data analytics. So more that is the first one, that the data analysis is more of analyzing historical data to get information, okay, to get information about what happened, okay. Then about that is what about data analytics. Of course, data analytics now uses the historical data to tell us about what will happen. One is about what happened, the other one is about what will happen. Okay, so mostly data analytics is more of predictive analysis. Okay, then data analysis is all about now you are analyzing what? Like you are analyzing historical data to get information. Okay, about that is about the data. All right, good. Now, during our regression analysis class, we discussed about dependent variable and independent variable. Okay, and we said dependent variable, also the known as criterion variable. Okay, it is like the variable which we are trying to understand, or variable which we are trying to what? To predict. Okay, then the independent variable, aka predictor variable or explanatory variable. Now it is the factor, or they are factors which influence the what? Our outcome. And our outcome is what? Is the dependent variable. Like for example, in a model with which we will build, the model used to determine the what? The umbrella cells, umbrella cells. Definitely this is our outcome. Like we want to determine, given a certain amount of rainfall, okay, or predicting a certain assuming we will receive a certain amount of rainfall, then it is possible for you to predict, okay, that is the umbrella cells which maybe we might sell during that period. Okay, so definitely this decision will help you, okay, will help you now to restock or to make some decisions. Like you will know which months you need to stock more umbrellas, and which months maybe you don't need to what? To stock that is umbrellas. Okay, all right, so in that case, that is our model will be umbrella cells given maybe a constant, let's say constant A. Then we'll have now the rainfall amount. Rainfall, this is F, rainfall, okay. That will be our what? Our X variable. This will be our Y variable, okay. Then plus another constant, maybe let's call it B. Okay, so definitely you can see this is also assuming a linear equation, okay, which is y is equals to a constant. We have a, let's say, let's assume it's a multiplied by x, okay, plus or minus b. Okay, so you can see we are having a linear expression or a linear equation, okay, in our model. Okay, so this is our model which we'll use to do what? To build that is like to predict future umbrella cells. Okay, all right. So basically, regression analysis helps you to understand how the dependent variable changes when one of the independent variable varies, and allows to mathematically determine which of these variable really has impact to our what? To our outcome, okay, or to our output. So technically, a regression analysis model is based on sum of squares, which is a mathematical way to express the expansion of what? Of that is of data points. I know we talked about, or we tackled that is sum of squares when majorly when we were dealing with variance, with standard deviation. Yes. So we are saying that which is mathematically way to find dispersion. Okay, dispersion of what? Of data points. Okay, remember dispersion, measures of dispersion, that is variance, standard deviation, and sometimes covariance. Okay, they are measures of dispersion or measures of variability. Okay, so the model of that is goal of a model is to get the smallest possible variance, okay, and draw a line that comes close to what? Closest to your data. All right, we shall see that. So in statistics, they differentiate between simple and multiple linear regression. Why? We talked about simple linear regression, and we said for simple linear regression, we have only one that is independent variable. Like we are trying to model or to find a relationship between a dependent variable and one independent variable, okay, using a linear function. That's what we were calling linear equation. Okay, linear function, linear equation. So if you use two or more explanatory variables to predict the dependent variable, you deal with what? Multiple linear regression. So remember, we also talked about multiple regression, where maybe you have that is more than what? More than two variables. Okay, let's say this will be b, okay, multiplied by x2, okay, then plus constant. So you can see in this case we have what? We have two independent variables, okay, predicting the that is the output. Okay, so in this case, this is what? This is a multiple. This is a multiple linear regression. Then for simple linear regression, we'll only have one independent variable. Okay, so you can see we have only one value of what? X. So this is a simple linear regression, and this is the regression which will be moving that is with it at this level. Okay, all right. So if the dependent variable is modeled as a nonlinear function, because the data relationship do not follow the straight line, then that does now no longer becomes a linear relationship, but now it uses nonlinear regression instead. Okay, it will now use nonlinear regression instead. Okay, or maybe you will have to do what? To do a linear regression. Like for example, like you have to convert it to linear regression. Like for example, let's assume we have this model that is y is equals to exponent of what? Exponent of x. Okay, so now for us to do what? To change this to linear regression, we'll have now to introduce logarithm. Okay, so meaning it will be log y okay, is equals to log exponent of what? Of x. Okay, so definitely you know this log exponent is the same as x log of e raised to what? To 1. Okay, so in this case now definitely you will what? You will now have that is you will treat this as your constant, and this will be our variable. So our final linear equation will be log y is equals to what? Is equals to x log exponent of, let's say, 1, okay, plus a constant c. And you can see now we are having what? We are having a linear relationship. Okay, so we had an exponential relationship, but now out of the exponential relationship, we've converted it to a linear relationship by applying what? Logarithm. So these are some of special cases which you can use to now what? To change that is non-linear regression to what? To a linear regression. Okay, or non-linear related variable, okay, to what? To a linear relationship. All right, I hope up to that point I'm clear. Am I clear up to that point? By show of hands, thumbs. Okay, Mohammed Abdallah Wangui, Deborah Tieno. Right, can see. Nice. All right, Mohammed. Thank you. Cool. So basically, that was just more of a recap. Okay. Yes, it was just more of a recap. So now I want us now to discuss about the methods of what? The different methods we can use to perform linear regression. Okay, so as an example, we'll take cells in numbers of for umbrella for the last maybe or for 24 months. Okay, and then we'll and also find out average rainfall, monthly rainfall for the same period. Then with that now we can perform what? We can try now to plot maybe information on a chart, and that is include a regression line so that we may demonstrate what? The relationship between the independent and dependent variable. Okay, so in this case we have three major methods to perform linear regression in Excel. Okay, linear regression. So we have the first method. It's by use of that is scatter chart. I guess it is written that scatter plot with what? Trend line. With trend line. Don't worry about my handwriting. I'm just drawing. Okay, I'm just drawing. So the second method now will use what we call data analysis toolpack. Data analysis toolpack. Okay, then the third it's now we'll use what we call inbuilt Excel functions. Excel functions. So definitely our aim is to get what? To get, we'll of course we'll get the same results. Okay, we'll get the same results, but doing what? But using what? Using these three methods. Okay, all right. And also this PDF, I will illustrate, and I will also share this PDF. Okay, and this PDF will give you also what? all that analysis. So you can see the regression, that is the regression tool, that is including analysis tool pack. We have scatter chart with trend line, and we have linear regression formulas in Excel. So these are the three methods which we are going to use to get what? To get the same output. Okay. All right. So I'm going to close that. Okay. Now, and then transition to the what? To the practicals. Let's start with the first method, that is scatter plot with what? With trend line. Okay. Yes. So this is our first method. Okay. This is our first method. Good. So basically, this is just to insert a we'll just insert a scatter plot. That will be our first objective. Okay. Now to do that, we'll come here, highlight our data. Make sure you select the month, you select the that is the rainfall, and also umbrella sales data. Okay. But even before that, we can try and see the trend, okay, of our data. Do like we can just make a simple plot, okay, to see how is the pattern, or what is the pattern of what, of our data set. Okay. So with that, we can just highlight all that is our data points. Okay. Then go to insert, then we have recommended charts. You can also go to individual charts if maybe you want to include column or bar chart, line, pie, scatter. This is the bar. All this, okay, even maps. All right. If at all you have what, you have country names, right? You can do what, you can include a map. Okay. Yes, so I usually prefer going to the recommendation, then I can go to the what? To the all, that is all charts. Okay, so I can examine which looks better. So I will go with line because I can see it's giving me a good trend here. Okay, I will go, then I can as well that is insert markers, just to have a clear vision, or a clear visibility of what, of our data points. Okay, and then I'll just click that, and then click OK. Okay, so you can see now this is what, this is our data. Okay, so definitely we have for a good, I know the property, I know this, we learned this from what, back from primary. Okay, like for a good graph, it must have how many elements? I guess I can't remember, they were 4 or 5. We must have a title, we must have a key, which is nowadays known as legend, we must have axis labels. Okay, all those. Okay, those are just examples. So in that case, um I of course I can try, we can add what, we can add this is just basic knowledge, so I'm not just assuming everyone knows, but I just want to cover it. Okay, so we can try now to add what we call now the already we have the legend, which is the key. Okay, you can see the key. From the key we can see that the blue thread line try to show us what, the amount of rainfall in millimeters, and then the orange one, it's what, the orange one shows us the umbrella cells. Okay, so we also have the title. Okay, but we are missing maybe the axis and also maybe the data points. Okay, so with that we can just say here we have That is, we can say this rainfall versus what? Umbrella cells. Umbrella cells. Okay. All right, just to have a simple title. Okay, then in case I want to now include the axis, like I know this is the amount of rainfall in millimeters, and these are the months. Okay, I can include as well. So with that, I can just come here. Okay, once on the graph, you'll see a plus here. All right, you'll also see a color, that is a chart style. So chart style basically gives you different options of that is the chart, the way you want the chart to appear. Okay, so we have very many and good that is um, styles, okay, which you can adopt. Okay, if you want, you can adopt this one. This looks good, but it doesn't have the markers, so I love when it has markers. Okay, also this is also good, but I love this one. Okay, with the markers. All right, I like the one with the markers. Okay, then if you can see now, it has also included what? The data labels. Okay, so in case you see maybe it is looking so busy and you don't want to include the data labels, you can always go to come to this plus. We have the plus. Now from the plus, we have data labels. If you want the data labels, you will always check, okay, on the data labels. If you don't want them, you can just uncheck. And once you uncheck, you'll see the data labels have disappeared. If you want them, you can include them. Okay. So if you want also the data tables, like you want this data to come here in a table format, you can always that is check the data table. Okay, but as well it will make your graph look so busy. Okay, then in case maybe now we need the axis, this is where we that is I needed. You can just click here. We need what? We need the axis. Okay, once you check the axis, you'll see now we have axis title. So in our case now it's just a matter of what? Renaming. So we'll say this, it's um what we can say, it is the rainfall amount, also stroke rainfall, because you can see we have that is the rainfall amount, and also we have the umbrella cells. So we can say we have rainfall stroke umbrella cells. Okay, so it's like we have a combined what axis on the on the y-axis, and then here definitely will go with what? With months. Okay, so what can we see from maybe from our graph? What we can see that mostly July's, they are the peak season, or they are it's them they are the months, or it's the month which we are receiving what? Which we are receiving high amount of rainfall. Okay, yes, and you can see even July of the following year. Okay, so you can see this is 2017 2016 and 2017. So for 2016 is January to December, then 2017 is January to December. So in that case, you can see the trend. Okay, then majorly in January, we usually receive less amount of rainfall together with March. Okay, yes, majorly these are the harvesting months. Okay, then you can see now from May, the amount of rainfall now it's increasing. Okay, so you can see the amount of rainfall is increasing. Then in July, according to the data, we are receiving what? The highest amount of rainfall. Okay, and we can see we are having the same trend. Okay, and also the same trend is appearing when it comes to what? When we model or when we plot our what? Our umbrella cells. So you can see at the point where we are having less amount of rainfall, also we are having a decline in what? In umbrella cells. Okay, where we have an that is an increase in amount of rainfall, we have also increase in what? Increase in that is in umbrella cells. Okay, even at the maximum amount of rainfall, we having the maximum amount of what? We having the maximum that is the maximum number of umbrella cells. All right. Yes. So in this case, you can see we having what? We are like we having a relationship. Whenever one variable is increasing, the other variable is as well increasing. So definitely from this case, you know that we are going to get a good correlation. Okay, we are going to get a good correlation between that is these two variables. Okay, those are some of insights which you can see in advance. Okay, so basically this was just to check maybe the trend or investigate maybe the trend of our data using what? Using uh, a presentation or a pictorial that is format. Okay, now back to the topic. Scatter plot with what? With trend line. Okay, scatter plot with trend line. So what our objective now, it's now to plot what? To plot the amount that is the amount of rainfall against what? Umbrella cells. Okay, so in that case we are just going to highlight maybe our data. Okay, now only the data, because we have the x value variable and y variable. Okay, so once you highlight the data, we know that rainfall should be on x-axis, and umbrella cells, what we are trying to predict, should be on what? Y-axis. Okay, so now to insert the first, that is the scatter plot, definitely you'll go to insert, then you can go to recommended if at all you want, then go to all. You can also go to all charts. Okay, and then we will need a scatter plot. Okay, so where is the scatter? Can you see scatter? Yes, we have XY scatter plot. Okay, once you click the XY scatter plot, you can see we have the first one. The first one, you can see, if you can remember, is trying to show us maybe the trend. Okay, but we don't want the trend. Okay, we need the one with what? With a relationship. Okay, like it's like it is plotting the coordinates, like the point where x is what? X is 82 and y is what? 15. Like basically x coordinates, that is coordinates, they are this one. They are always, is it x, y, x, comma, y. Remember, these are the what? These are the coordinates, x, y coordinates. Okay, so these are our coordinates. All right, and that is when you use that coordinates to that is to plot this data, you'll get something like this. Okay, so we'll just say okay, and you can see this is a scatter plot. Okay, and in this scatter plot is trying to show us, like, for example, let me just take one data point here. Okay, so this data point is for that is umbrella. You can see the coordinates here. You can see on this that is, you can see the coordinates where we have 165.4 comma then we have what? We have the that is the y coordinate. Okay, 165.4 comma 50, which is now x y coordinate. Okay, all right. So with that, let's continue now. We've already inserted what? The scatter plot. Okay, scatter plot, we have it. If you want to include the x titles, that is all the x-axis titles, you can always. So this is the rainfall amount in what? In millimeters. And then this is what? This is um, rainfall amount. Then we have umbrella cells. Umbrella cells. Okay. All right. So now we want to include what we call what we call trend line. Okay. We want now to include what we call trend line. Okay. So under trend line, what do we need that is under trend line? Okay, so under trend line now basically shows it's like we need a line, a linear relationship, something which will show us linear relationship. Okay, okay, so with that now we'll have to come to, we have now the plus sign. Okay, then under the plus sign you can see we have what, also we have the legend in case maybe you want the legend. Okay, also and but now our point of concentration is what, the trend line. Okay, once you come to where we have the trend line, you'll see that is an arrow, okay, facing to the right, so you can click that arrow. Okay, then come here, we if you want maybe a trend line, it's either linear, it can be an exponential trend line, or it can be a linear forecast. Okay, or it can be what, 2 period moving average when it comes to time series. Okay, this is for time series. Then for us we can even go to what, to more options. Okay, you can click more options and see what we have. Okay, so in our case now, of course, it's a linear relationship. Okay, so we'll just choose what, the linear relationship. So in this case, just choose the linear relationship. Okay, then you can if you want maybe to forecast. Okay, if you want to forecast up, that is forward, you can even include maybe a percentage. Okay, you can include a percentage of maybe uh, of your forecast. Okay, if you want it to be 20%. Okay, first of all, before I can just that is forecast forward, you can see already that is the last point of what, the last point of the line or of the trend line. Okay, so once I click enter, you can see it has what, it has projected. Why? Because now I'm projecting a value up here. Okay, so at this point you can even search that is a value at this point, like I've tried to what, to project forward. Okay, I've tried to project forward. All right, yes, back to normal. If you want to project backward, meaning now it will project something before here. Okay, so like for example, if I need like a 50% backward projection, okay, I can just write 50 and then you can see. Okay, so even before we can continue, I know. Okay, because this is like the line of best fit. You know that this is like the line of the best fit. Okay, so basically what I have maybe from my side, okay, depending with the knowledge I have, I know our constant or our y-intercept will come to be what, will come to be on the negative side, like it will be something like this. Okay, so this is the x-axis and this is the y-axis, so it will come to be something like this. This will be my regression line, this one, meaning it will, that is our y-intercept. Okay, will be what, on the negative side of what, of y. You can, it's even evident here because you can see where the regression, after doing a backward that is projection or forecast, you can see where the that is the regression line is. It's cutting the what? You can see it's already cutting the x-axis, okay, on the what? On the positive side, okay. What if maybe I take it to 99%? You can see if I take it to 99%, you can see it's already cutting, okay. This regression line, that is the if we do the backward projection, it's already cutting the what? The y-axis at the negative, maybe at negative, let's say negative 18, somewhere there, at negative 18.99 or 18.8 point something, okay. Yes, so that's how maybe you can that is try to play with what? With these forecasts, okay. All right, good. There is now something which I will need to set, maybe I will need to that is to show what, like to display the equation of the line, and I will also need r squared value. Remember we said that r squared value shows us the what? Shows us the coefficient of determination, okay, like the goodness of it. How is our model performance? Okay, what is our model performance? Okay, so in that case, I'll just check display equation on the chart, and also display r squared on the what? On the value, okay. And you can see it has now included some values here, okay. Yes, these are the values. So you can see our r squared is 0.91, meaning our model performance is 91%. Okay, like 91% of our data points are within what? Are within our regression line. All they are being used in what? In our model. Then our model is this one. That is, this equation is our new model, and that is, my conclusion was very correct, okay. You can see where that is the, you can see the value of what? The value of our y-intercept, it's a negative value, and it's negative what? Negative 18, okay. It is cutting the, that is the y-axis at negative 18.9, okay. Yes. So definitely now this is what? This will be our model. Okay. That is y is equals to this. Okay. Then we have our what? R squared. If now we were to write this in our, that is in the model format, then now we'll have something like this. Or we'll come and say now umbrella, okay, umbrella cells will be equal to, okay, what value did we get? 0.4482. Okay, it will be 0.4482 multiplied by amount of rainfall. So we have rainfall multiplied by rainfall, okay, minus our y-intercept, okay, it was negative 18.915, okay, so minus 18.915. Then now this is what? This is our model. This is our model, okay. So this is our model, okay. Take note of that. This is our model, and maybe we can use it, you can use to predict it, okay. So let's assume maybe a value. I just want maybe a value like this is January, okay, this is January, and then I'll come and paste it, okay. So I want now to use my model, okay, to predict. Even let me change it to 8, that is 82.5. Okay, I want now to use my model, okay, to predict what? To predict maybe the umbrella cells. Let's assume this is 2018 and I'm predicting the amount of rainfall in January will be 82 point what? 0.5. Okay, or yes, let me say 82.5. Okay, yes. So with that now I can come and say equal to, all right, I can as well write the model here. Okay, I can as well write the model here, like say that is this is what, this will be our y. Okay, this will be our y value. Okay, so what do I need? I need the slope here. I need the value of the slope, or our that is our x variable constant. Okay, I will also need that is the x variable. Okay, x variable, which variable, which we already have it. It is what is that is 82.5, and then we'll need what, our y intercept. Okay, so in this case we know that our slope is what? Our slope is 0.4482. Okay, then our x variable, we know it will be this one, so it will be equal to this. Okay, it will be equal to this. All right, and then we have our intercept. We know our intercept is negative 18.915. Okay, that's what, this is our y-intercept. Okay, so let's calculate, or let's project what, our umbrella cells. So our umbrella cells will be equal to, okay, the slope, remember that, so we can even put it in brackets. We know it is the slope multiplied by, okay, the x variable. Okay, then we can close. So in this case we have what, we have this part 0.4482x. We have the slope, we have the x variable. Okay, then we will now add, okay, we'll now add our negative value. So you will now add this negative value. Okay, so basically it's negative, so plus minus, it's what, it's minus, so it will now come to what, to this. Okay, it will now come to this. Okay, that is, and since it's umbrellas, we can report that as a whole number. So we are getting what, we are getting 18 umbrella cells. Okay, so we are assuming if the amount of rainfall, okay, it's if the amount of rainfall in January, okay, will be 82.5, then most probably we'll sell, okay, 18 umbrellas, or 15 to 20 umbrellas, plus or minus 5, because of what, because of the error term. Okay, why? Because you can see our model, it's not 100% when it comes to performance. Okay, it is 91%, so we still have 9%, that is before we can meet what, the 100% performance. Okay, or the 100% accuracy. Okay, that's why you can see previously here we had what, here we had a rainfall amount of 82, but we sold 15 umbrellas. But here now we are saying we will sell what, 18 umbrellas. Okay, yes, so you can see that plus or minus 5. Okay, yeah, in this case, or in this case we can say plus or minus let's say yes, plus or minus 5, no problem. All right, good. Any question up to that point? If we are together, maybe by show of thumbs, please let me see. Okay, Mohammed, nice one. Seems you are happy. Okay, I hope all of us are good, right? Everything was clear. All right, well and good. Now I want us now to jump to the second method and see if we'll get what? If we'll get the same values. Okay, all right. I will also show you when it comes to when it comes to the that is the Excel the Excel inbuilt function. Will also I will also add you some bonus and show you how you can use that is the linear, okay, the linear or the forecast linear function to forecast, okay, and also how we can use the trade, okay, the trade function to do what? To forecast or to forecast, okay. Yes, so I will just add that to you as bonus. Good. So I'm going to that is copy this data and paste it in what? In a new sheet, so that we may not interfere with what? With the first sheet working. All right. Good. The second method, okay, using analysis toolpack. So this is our second method, okay. So for the second method, we are now going to use the analysis toolpack, okay. I guess I had in the previous class I had tried to run the results, okay. So I'm going to start with data, okay. We are going to the data analysis toolpack, so I'll go to data, okay, then go to data analysis. Under data analysis, come here and search what we call regression, and you can see we have regression here, okay. Then you can click OK. Sawa, you can now click OK. Once you click OK, it will now direct you to, or it will bring a pop-up window, okay, telling you to input the Y range and to input X range, okay. So in that case, we are going to start with our Y range, okay. You can either select only the data points only. You can also select with the label, but make sure you check labels here, okay. So with this, we are going to that is we are going to start with the y-axis. So make sure you are checked on the y-axis. So select umbrella cells, okay, up to that point. Then after selecting the umbrella cells, come to the X input. All right, highlight and select what? Select the rainfall amount that is data, okay. Then of course check labels. Why? Because our first that is raw here, or the we've even selected the what? The title that is raw, okay. Then after that, now we want the output range, okay. Where do you want your output to be? So we can now maybe just check anywhere, okay. I want my output to be in the same worksheet, okay. So I will just select a specific cell. You can select inside here and then select maybe a specific what? A specific cell. So I'm going to select maybe this cell, okay. Then after that you can do what we call okay. Click OK. Once you click OK, okay, once you click OK, it will give you it will give you this kind of analysis. Okay, it will give you this kind of analysis. You will have that is the summary output. Okay, you will have the ANOVA. This is the analysis of variance part, and then you will also have your residual. That is um, the residual output. Okay, you'll also have the residual output, right? Okay, good. Now, all right, now let's do what we call what? Let's do what we, that is, let's now do the analysis. Just a minute. Let's now do the analysis, okay? Or do what we call the interpretation, okay? So for my case, for today, I'm going to interpret the output summary, and then now from tomorrow we'll start with what? With ANOVA. Okay, that is the analysis of variance. Good. Let's start with the summary output. I can remember yesterday talking about multiple R. Okay, and for multiple R, I can remember telling you that multiple R basically is the coefficient of correlation. Okay, so this is what basically our correlation. Okay, so if it's our correlation, what does this value mean? So from the value you can see we have that is a very strong, okay, not a perfect one, or not a perfect correlation, but you can see we have what we have, that is a multiple. Okay, we have multiple sorry, we have a strong, very strong correlation. Okay, you can see we have a very strong correlation between what, between these two variables. Okay, we have a very strong correlation between these two variables. Okay, yes, so maybe we can try and build a correlation matrix of the same. Okay, we can try and build correlation matrix of the same and see that is the correlation. So with that, I can also just as a bonus, you can go to data analysis, then go to what, we have correlation. Okay, select correlation, then you need what, you need this data point, so you can just select all those data points. Okay, then you can select labels in the first row, yes, correct, and then I want the output in roles, and then I will, that is my output. Okay, I want my output in the same what, workbook, so I'll just click on the same worksheet. Okay, I'll just click on the same worksheet, and then I can select maybe a cell here, okay, to print my output. So once I print my output, you can see what we are getting here. Okay, we are getting what we call that is called correlation matrix. Okay, correlation matrix. Like for example, rainfall and rainfall, if we are trying to get maybe correlation between rainfall and rainfall itself, definitely we'll have what, a perfect correlation. Okay, because rainfall will 100% explain about what, rainfall. Then you can see the rainfall, that is the rainfall amount and umbrella cells. Okay, or umbrella cells and rainfall amount. Okay, will get a correlation of what, 0.95. Okay, and then for umbrella and umbrella we'll have what, we'll have a perfect correlation. So this is called correlation matrix. Okay, yes, so let's go back to correlation. So basically we've seen that we have very strong correlation here, meaning that is one variable is increasing. Okay, the other variable is also increasing. Okay, all right, now Let's go to r squared. So for r squared, I can remember I talked about it. You can see it's the same value we got here. Okay, it is basically the that is the coefficient of determination, or it shows us the that is the model performance. Okay, it shows us the model performance. So we can say 95, no, sorry, 91% of this data was used to build what? To build our model. Okay, or 91% of our data was consumed while building what? A model. Okay, so like we can say, what is the performance of our model? We can say it's 91%. Okay, right. Then we have adjusted r squared. But I can remember, yes, that is in our last class. I told you that for adjusted r squared, it's basically used when we have what? We have that is we have we are talking about multiple linear regression. Why do we have the difference? It's because of that is hyperparameter tuning. Okay, it's because of hyperparameter tuning, meaning we can have some deviation. Okay, when maybe we have more parameter than when we have one parameter. Okay, so when we are dealing with multiple linear regression, adjusted r is preferable. Okay, yes. Then we have standard error. You can also remember that when I was talking about standard error, I said that standard error, it's also useful. Okay, that is, or it can also help us to know that is if our model it's a good model. Okay, you remember me telling you any value closer to what? Closer to 0. Okay, we can say in that case it's what? It's a good model. Okay, it's a good model because you can see this. Okay, you can see this 3.5, it's near to 0. Okay, compared if we got a value like 20. Okay, definitely if we got a value like 20, definitely the what? The multiple r value will be as well less. Okay, it will be less. So in this case, you can see standard error, it's very small, so we can really conclude that this is a good model. Okay, all right. Then we have observations. Okay, so from the observations, you can see now we have of course we had 24 observation in count. That is the count of data values. So you can see it's 24 here. Okay, then we have the intercepts. Okay, so you can see these are the same intercepts which we got. We have the y-intercept and we have the slope. Okay, the coefficient. So you can see that here the coefficients are the same as these ones. Okay, you can see the coefficients are the same as these ones. Okay, 0.4482. Here we have 0.4482 rounded off. Then for the intercept, we have 18.915. Here we have 18.91. All right. Did you lose me, guys? At what point did you lose me?
Yes, you went quiet.
At what point? I guess it's my network.
After you highlighted the coefficients.
Okay, yes. So, good. That's better. At least I thought I maybe you lost me even before I can produce this output. Thank you for that, um, Wangui. So, for this, I was saying that for intercept, you can see that is for the slope. You can see we are getting the same value as this one, which is 0.4482. Okay, you can see this is the same value we are getting here. Then for y-intercept, you can see we are having a negative 18.91478. If we round off those decimals, definitely you'll have this value. Okay, so meaning that is the two different methods having the same what? Having the same results. Okay. Yes. So for the ANOVA, we will discuss tomorrow. Okay. Let's maybe check what that is the results. That is also what the notes are telling us. Okay. All right. Good. So we had the multiple R. So for the multiple R, we are saying that it is the coefficient, a correlation coefficient, as I had told you, okay, and measures the strength of the what? Of the linear relationship between the two variables. So the correlation coefficient can be any value between -1 and 1. We had already tackled this, and its absolute value indicates the strength of the relationship. The larger the absolute value, the stronger the relationship. 1 means we have a strong positive relationship. -1 means we have a strong negative relationship. 0 means we totally don't have what? Any relationship. So in this case, you can see our values is 0.95, meaning we are moving towards what? 1. So we can say it's a what? We have a very strong relationship between what? Between these two variables. Okay. Yes, like any external factor which will impact one variable, okay, will also take the same impact of 95% to what? To the other variable. Okay. All right. Let's continue. R squared. Okay. So R square is the coefficient of determination. I can remember telling you that, okay, which is used as an indicator of goodness of fit. Okay, it shows us the goodness of it. So it shows how many points fall on the regression line, like how many data points were used to what? To build the model. Okay, and also to create the regression line. Okay, so R squared value is calculated from the total sum of squares. That is precisely, it is the sum of the squared deviations of the original data from the what? From the mean. Okay, so like in our example, R squared is of 0.91 rounded into 2 decimal, which is fairly good. Why? Because it means that 91% of our values fit the regression analysis model. Okay. In other words, 91% of the dependent variables are explained by the what? By the independent variable x values. Generally, R squared of 95% or more is considered as a good fit. Okay. Then we have the adjusted R square. So it is the R squared adjusted for the number of independent variables in the what? In the model. You will want to use this value instead of what? R squared. That is for what? For multiple linear regression. Okay, that's why I said adjusted R. It's majorly used when it comes to what? To multiple linear regression. Okay, then we have the last one, which is standard error. We said that standard error is also another goodness of fit measure that shows the precision of your regression analysis. The smaller the number, the more certain you can be about your regression equation. While R squared represents the percentage of the dependent variable variance that is explained by model, standard error is an absolute measure that shows the average distance, okay, that the data points fall from the what? From the regression line, meaning like all our data points, okay, are what? Are within along or not far from the what? Regression line, okay, compared to this. So in this case, here we'll have very what? Like a very big value of standard error. Okay. Then observation is simply the number of observations in your model. Okay. Yes.